Hello everyone, and welcome back to Reverse Engineering Linux 32-bit applications. In this video, we're going to continue our discussion of format string errors. In particular, we're going to show you a couple of different ways you can crash an application that has this problem. So in a previous video, we had this very simple program. All it did was receive input on the command line, and then it would output that information using printf. So how can we cause this program to crash? We can use a number of different format string specifiers in order to crash this app. So let me go ahead and do this. I am going to run this through EDB. And we'll start with this. I will give it %s, %s, %s. I'll give it 4 of these. And we'll see what this does. Now, just as a reminder, I'm running this under Linux, of course. And I'm using single quotes. Single quote says, hey, Linux, do not interpret the stuff inside these quotes. It's not for you, Mr. Bash Shell. So here's our program. Let me go ahead and step through this library code. And now I'm into my actual code. As we've done before, I'll go ahead and analyze this section. And we will go forward into our main method. Okay, so here we are in our main method. I'm going to go ahead and set a breakpoint. And we'll step through this. And you'll notice here it says this program prints what the user inputs. Go ahead and step a little further. And now I'm getting ready to call my printf. And of course, as we've seen before, I don't call it directly. I'm going to use the PLT because it's relocatable code. And here's my stack. So it has on the stack these %s, 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 %s. So this says, hey, I would like to print 4 strings, please. Now, where does it get the addresses for these 4 strings? We talked about this before. We said that when you call a function and you're using the cdecl calling convention, which is what we have to use here, recall that when you have multiple arguments that you can accept a varying number of arguments, you have to use cdecl. And those arguments are pushed onto the stack, and they are pushed from right to left. So here was my first argument, these %s's. Now, I didn't give the other arguments. So what's going to happen here is it's going to assume these next 4 items are my string addresses. And these are somewhat random items here on my stack. Now, it turns out that some of these addresses are addresses on the stack. And here we have a return address where I'm going to go after I've made this call, etc., etc. So there's a good chance that one of these is not valid, and this will crash my program. So let's see if I'm right. Let me step. And it says in this case, it exited normally. So it exited normally, and it displayed a bunch of random junk to the screen. So let's see if we can improve on this. How do we improve on it? Pretty easily. We give it more of these strings. Now, if the programmer was somewhat smart and they used stir in copy, it would truncate this after a little bit. So that's something I should be aware of. So let me try just a few more of these, and let's see how this will go. I've gotten to my breakpoint. I'll go ahead and analyze. I will step forward. I'm ready to call my new function. And if I look at my stack, I will see that there are a couple of null bytes on my stack. So that's a problem for me, because I am going to try to print information that is at a null address, which is invalid. So let's see what happens if I step here. Boom. Says, I'm sorry, but address 0000002 does not appear to be mapped. So it did not like my format string that I passed in, and I caused this program to crash. So that's one way to crash a program. What's another way to crash a program? Well, this one, it turns out it's much simpler and easier. And that is to use an obscure format string specifier %n. You might say, well, what the heck is that? I've never used it. I have never used it in a legit program either. %n will write a value to a integer. So it is looking for an integer address where it can write the number of things passed into printf, or it doesn't again have to be actually printf. It could be fprintf or a whole family of functions that will use format strings. So I can throw in just a couple of %n's and it's very likely that it'll crash. Now, why is it very likely that it'll crash? There's always a chance that I don't have on my stack an address that doesn't point to a valid area of memory that could contain a string. However, if I use %n, I'm trying to write to an address. Now recall, especially in the Linux world, that we're pretty smart about how we set up our memory, and we set up our segments so that executable segments are not writable, because that's bad. So what does this mean? This means that I can try to write to an executable section of code, of memory, I should say, and it's going to fail. Well, I'm pretty sure that I'm going to find such things on my stack, because what's on my stack? A bunch of return addresses for all of my function calls. So that's part of the frame that gets put on for every function call. So this is virtually guaranteed to crash. So let's go ahead and do this. Once again, I'll run to my breakpoint, do my analysis. And let's see what happens in this case. I will step forward. So here I am. I am going to try to output this value several places. And here are my pointers. This is a place on the stack, and this is not on the stack. This is in fact a return address. So really I only needed 3 of these, and it should crash my program. So let me go ahead and step, crash. Sure enough, what did it tell me? It said, this address could not be accessed. Now, in some future videos, we will show you some attacks that you can do where you can write to various parts of memory, and we'll discuss how that can be done. But in this video, we showed you 2 quick ways that you could crash an application. So you could definitely do a denial of service attack. In this course, we talk about how do you locate these things. Well, this one's pretty easy. You can just search through the program and see if they're using printf, which they probably are. So it's a very, very simple way to see what's going on with the program. So let me go ahead and stop this. Now you might say, how could I know if they're using printf or similar functions? There's a couple of different ways you could do this. Very simple-minded way. You can run strings on your application. So I can run strings on format string, and I can pipe that to grep for printf. And sure enough, it's being used. I could do much more sophisticated things where I actually look at what's being called. We've used ltrace before. Now ltrace, of course, will actually run the program. I'll give it some input. I'll just give it 42. And I'll pipe that to grep printf again. Oops, I forgot the dot slash. And sure enough, it says, yep, this program called printf, and it passed it 42. I could try the same thing with strace. Strace will give me system calls. So here you'll see the call to write. It's a little bit harder to use this instead and figure out that write is going to write to the terminal. So they're using printf. I would probably use ltrace instead. And there's a lot of other ways you could go. Of course, you could use Evans debugger or really any debugger, even GDB, and you could search through there and look for calls to this particular function and notice whether or not there are multiple arguments being passed to that function. And of course, if you're tracing through the code, you can figure out if the user possibly has control of that code. So that's a little bit about how I can crash a program that has a format string error. And that is pretty much what I wanted to talk about in this video. Now, as a reminder, this video is one in a whole family of videos and courses that we have here at Pen Tester Academy, your source for everything InfoSec. And I look forward to seeing you in this course or another course soon. See you then.